Okay, so that said, I'm Kyle. My background is I've been in programming for a very long time, started writing code in '81, worked with my dad's software shop for several years after '81, moved into teaching in the '90s, got tired of teaching, moved back into software, but I really like teaching, so I ended up doing teaching of software somewhere around in 2000. I discovered the extreme programming method of doing Agile software, and since 2000 I have been a consistent both advocate and practitioner and frequent trainer of extreme programming. In 2001, the Agile Manifesto was signed, and an awful lot of Agile drifted in the direction of process-focused Agile. In the mid-late 2000s, and from my point of view, the world is finally coming to its senses and realizing that the technical side of Agile is at least as important as the people and process side of Agile. So we have 2.5 hours. We have 2.5 hours of time, and in that 2.5 hours, we're going to spend something like half of the time on Agile engineering topics. We're going to spend something like half of that time on Agile quality topics. I normally do this approach as a 4-day course. We've got 2.5 hours, so we're doing the highlights of what you need to pay attention to, what you need to know. We'll take 10 or 15 minutes in the middle of that time for a break, and that's our schedule. Any questions? None of you can say anything, but if you had questions, you could use the questions panel to say so. Okay, I am moving forward on this, and the session is currently being recorded just so that if you find this useful and somebody on your team had missed it, want them to come see it, they will be able to do that later. Let's go ahead and get started on the Agile engineering front. Go. Okay. First thing, so there was a request for my full name. I just don't like anybody to call me Mr. Griffin. My name's Kyle. I answer to Kyle. I don't really answer to Griffin. But there was a request for my full name, so there it is. Okay, Kyle Griffin. There it is. Okay, so this isn't the important part. Let's go ahead and look at this. The thing that I want to talk about here is what is Agile and what is technical Agile. Then I'm going to talk about theory and practices, and if we can get a minute, we'll show you a little bit of Agile as done technically. And I have a minute here. So important thing to note about Agile. If somebody comes to you and says, oh, this is a simple explanation of what Agile is about, pretty much they're wrong. Agile doesn't really have a simple explanation. If you are looking at Agile, I'm sorry, I'm having trouble with my, auto transitions here. and apologies for that. There's a bunch of different ways you can look at Agile. And I want to just go through them quickly because most people don't have any idea that there's more than one way to look at Agile. The first easiest way to look at Agile is to say, look, Agile is a historical development. Once upon a time in the 1950s, it took us a month to go from I discovered an error to I fixed the error and confirmed that it was fixed. In the Unix world, it was possible to do that. I'm sorry, I am going to switch my approach here because I am going to sorry, there's this, okay, I'm going to do it this way. Because I really don't like the screen transitions going on. Apologies for this. Here we go. So one way of doing this, software history. We have Agile is understandable as a response. In the 50s, it took forever to get a fix from code, from find a problem to fix it. In the 70s, if you're writing shell scripts in Unix, I write a script, I have a problem, I debug it, rerun it, and test it again, all inside of 5 minutes frequently. The difference between those is enormous. In the 1980s, we had big software projects failing, and so we ended up with teams instituting a process to try and prevent failures of $10 and $100 million projects, and so we got formal processes like waterfall. Waterfall involved lots of coordination activities, lots of documentation, lots of carefulness, and very simply, it wasn't that much fun. The first and easiest way to understand Agile is a response when the software developers who were tinkers, who liked writing code in the 70s, ran into heavyweight process, which meant you didn't get to write that much code. You had to do lots of documentation, you had to do lots of diagrams. And Agile was a response to waterfall. First off, they said it wasn't actually improving the success rates that much. And second, it was no fun as somebody who signed up to be a developer so that we could write code. And so if you're not looking at Agile from the point of view of waterfall is a very unpleasant thing to do from a developer's point of view, and many developers signed up to be developers because they wanted to write code, you're missing an angle of Agile. Those of us who've been in the Agile industry for long enough have a second point of view here. Second point of view is Agile is an umbrella term. It comes from a bunch of different methods: extreme programming, DSDM, Scrum, Crystal, Kanban, SAFe, LESS, lean software development, disciplined Agile delivery, behavior-driven development, DevOps, adaptive, modern Agile. There's a zillion Agile methods. Basically, all these guys got together in Utah in 2001, or rather the top half of those folks did, met and said, what do we all agree on? Agile is a term used to explain the commonalities between a bunch of different methods. Third point of view, I get into arguments with friends of mine. I come from this Agile umbrella point of view. Many of my friends come from the Agile manifesto point of view. Agile is what it says in the manifesto. Here's what the manifesto said. It says that some things are more important than others. Individuals and interactions are more important than processes and tools. Responding to change is more important than following a plan. That's the manifesto. The manifesto has 4 values and 12 principles. I'm not going to go through those. That's for a different kind of class. Some people understand Agile from the point of view of the manifesto. Another set of people look at Agile and go, oh, I recognize that. That's the same as what we're doing over here in some other domain. The biggest areas where that's true is the lean manufacturing space. What happens when you have complex adaptive systems that you cannot successfully predict the results of? If you have complex adaptive systems that you can't predict the results of, then you basically are stuck. Instead of relying on experts or instead of relying on good plans, you have to take an empirical approach. Science is the name of the empirical approach that we tend to default to. So my screen is saying that y'all are not necessarily seeing my screen. I can't quite tell if I'm moving too fast and the screen's not changing for you. You have to let me know. That said, science is the basic approach that says, I'm not going to rely on a plan. I'm not going to rely on an expert. I'm going to go out and run a test and see what actually happens. My claim is there's a set of methods that are in different areas where this is applied. Lean is what happened when you said, let's be empirical about manufacturing processes. UDA is what happened when thank you for those who told me that you can see the screen. I appreciate it. UDA is what happened when the military ran into the question of how do you run stuff in a highly empirical fashion where none of your plans are expected to survive contact with the enemy. How do we run that kind of thing? It's far more complicated than that, but we're not here to discuss UDA. There's also other systems, but Lean and UDA are the 2 other really well-known systems where people have said, look, we've got a bunch of human beings trying to operate in a highly unpredictable world. How do you do teamwork and effective delivery of what we need in a highly unpredictable world? Lean and UDA are what we've got. The other one, science, the evolutionary theory, free marketeering, the mathematical study of chaos, computers, complex adaptive systems, and evolutionary algorithms, and game of life, and cellular automata. All about what happens when predictivity isn't there. Agile is the same basic idea, different domain. When I look at my almost 20 years of Agile background and say, okay, what's Agile really about? I say there's 3 reasonable methods of solving any type of problem you like. One of the methods I call hero. The Project Management Institute calls it cowboy. Most problems in the world are solved by hero methods. Get somebody who knows what they're doing, let them solve it quickly, leave them alone. Most of the rest of the problems in the world, like building a skyscraper, are solved by bureaucracy. Let's coordinate. Let's basically try and get a whole bunch of people to work together. And the way we're going to do that is we're going to say, okay, here's the project we're trying to do. Let's make a plan. Let's be careful with our plan. Let's make a schedule. Let's be careful with our schedule, and let's manage to the schedule. Agile, on the other hand, says the goal isn't get something done right now. It isn't do coordination. It's to handle change. The time scale is different. We're looking across the product lifespan, and we run off of feedback, focus, and collaboration or teams instead of basically relying on planning, schedule, and management, or relying on expertise, interruptions, and independence. Different ways. So, and I'm not even going to talk much about this. I will in a sec. The fact is, there's a whole bunch of different ways you can look at Agile. Most people who say, oh, Agile is this simple thing, they're saying Agile is this simple thing because they don't know enough. Agile is a very complex thing. How you want to define it varies from person to person. Ask 100 Agilists what they call Agile. You'll get at least 20 different answers. I've given 6 of the top ones. I didn't do the mindset version, right? There's a bunch of answers. And I need us all to be on that page as we're getting started. Now, when you're doing Agile, when you say, okay, yeah, this is an interesting thing, we'd like to do Agile, then the question is, what parts of Agile do you want to do? One part of Agile, the part everybody knows about, is the Scrum or Kanban part of Agile. It's process. It's a lot like project management, but if you tell that to any Agile person, they're going to say, no, it's not project management. It doesn't require the same mindset. Yes, all that's true. That's fine. But it's still near the category of project management or process Agile. In reality, if you bring in somebody to support Agile, 80% of what somebody in an organization who understands Agile is trying to do is they are trying to get your teams to operate effectively as teams. The process part is nice, but the important part is making the team work. And this is basically true for Agile coaches. How do you get teams to function is the core question in agility, and the formal ceremonies are things that we have in place to allow the team to function and to try and draw grooves in the ground to make the team roll in a specific direction. The product part of Agile is an entirely different area. How, given an Agile team, do you then have to change what your product work is? I go on rants for an hour or 3 about how this is an incredibly hard problem, and most discussions of Agile don't take how hard of a problem product Agile is seriously. I'm going to leave that alone for right now and just say product area. The decision of what to build rather than the decision of the process to run building it or how to make a team effective is a different category. Enterprise Agile is a 4th well-known category of Agile. How do you work in Agile outside of the boundaries of one team? What do you need to do in the enterprise to change in order to support Agile? Big topic. There's SAFe, there's LESS, there's DAD. I have a custom approach to that myself. There's a whole bunch of different ways to do Enterprise Agile, but if you don't do Enterprise Agile, anything that you're doing at the team level will eventually just be absorbed back into doing it the old way while calling it Agile. Fix the enterprise or it's not going to stick as a change. And then there's Technical Agile. And Technical Agile is one name for what this course is about. But I needed to contextualize. A lot of people think of Agile as being something smaller than what I just talked about. Agile's pretty wide. So, Technical Agile. Short version, what is it? Technical Agile, as of today, is an amalgam of 3 different, though very related, sources of information. Extreme programming, the Chrysler C3 project running through about 99 until Chrysler was purchased and the project was canceled. That was run for the last 3-ish years of the project in an extreme programming fashion. Extreme programming was the distillation of best technical practices to do software for a rapid type delivery in 96 to 99. Almost everybody who went to the original Agile Manifesto signing was familiar with and to some extent doing extreme programming. The Agile people were going to extreme programming conferences at that point, and many people thought that the foundation of agility was not the process, it was the software practices. Even folks like the founders of Scrum say, look, you can do Agile, but I've never seen somebody doing Agile effectively without the Agile technical practices. That is also my personal experience. I think of the technical practices in Agile as foundational, more important than the team practices of Agile. And the team practices of Agile are more work than any of the rest of it. However, the Agile as a movement shifted away from technical practices after 2001, 2002, and moved off mostly in the process direction, focused on Scrum, focused on generic Agile, some Kanban stuff, but it was mostly project management level discussions, not technical practices discussions. And so in about 2008, two separate alternative things happened. In one Agile conference in 2008, there was a talk that was supposed to happen on Agile infrastructure. Agile infrastructure came up and nobody showed up for the talk. And so the presenter didn't show up for the talk. And so somebody else walked in late because it was an interesting topic to him. And eventually the person who walked in late and the person who was trying to give the talk got together and formed a movement called Agile Infrastructure, which they later renamed into DevOps. To a significant extent, DevOps is taking the principles we knew from extreme programming in 98, 99, focusing on the build and deploy parts of it, but not exclusively on the build and deploy parts of it, and expanding it to include modern tooling, because tooling has changed incredibly much since 98, 99 when we started this whole extreme programming thing. The other thing that happened was that at a different Agile conference, one of the original manifesto attendees, Uncle Bob Martin, he gave a talk suggesting, hey, we need a fifth value in the original Agile manifesto. And the other four values are individuals and interactions over processes and tools, etc., etc. He recommended that we take in a fifth value, and his fifth value was, as you see on the screen, it was in favor of paying attention to the quality of your code, right? Those of us who've been in technical Agile for some period of time don't believe you can actually sustain Agile at any rate without dramatically improving the average quality of your code. And so Uncle Bob gave a talk on software craftsmanship, and that has turned into a movement, software craftsmanship. That also happened in 2008. If you say to somebody, what is technical Agile? Mostly it's an outgrowth of these three sources. If you wanted to add in a fourth source, you'd say there's a bunch of test automation going on, and automated testing tooling has also made a big deal difference in this space. So what's extreme programming? Extreme programming says, hey, we're going to focus on what the individual developer does on a minute-to-minute basis in your code. It's a really different way of writing software. It is, to some extent, the immediate precursor to the Agile Manifesto. Software Craftsmanship says, look, you can't call software engineering. It is a it is an approach that says, look, historically we've talked about software as engineering. Engineering involves a lot of planning. If you are an engineer, you learn to be an engineer one way. If you are a blacksmith, you learn to do it a very different way. It's an awful lot of your design comes out to when you're pounding the hammer, you have to change, and it's your experience pounding the hammer where you're doing most of your design. It's not drawing the pictures for design. It's being in the middle of doing and shaping. That is where the design happens. There's several people who've been attached to the software craftsmanship name. The biggest name is Uncle Bob, but it's not the only name. DevOps is beyond what we're talking about here. We're not even really talking about it in other parts of this. It was originally Agile infrastructure. What happens? What do you need to do to make dev and ops talk to each other? Stop passing things over the fence and blaming each other. If you talk to 10 people and ask them what DevOps is, you might get 12 answers. So this is a really tricky one to say. Being as I'm an extreme programming guy, I think of DevOps as taking most of extreme programming's insights, restating them, and then focusing on the integration, delivery, deployment side of things by means of scheduling software like Jenkins, virtualization, containerization, provisioning, and such. Easiest way to say it. Okay, so there's lots of stuff we can focus on. I come from XP. I think of the software craftsmanship people as saying very similar things most of the time. I think of the DevOps people as focusing different and saying very similar things most of the time. But I'm going to come at this from an extreme programming point of view because that's what I was doing almost 20 years ago and still where I am. I'm not going to go through all of XP. A couple things you need to know about extreme programming. Here's XP's theory. Traditional IT projects fail a lot. If you've ever heard anybody talk about Agile, they've waved around the chaos reports from Standish. They say, hey, look, here is the way software is being done right now. We've got all these waterfall projects and they're all failing and the rest of them are late and over budget, and look, it's not working. So what can we do instead? So the people doing XP were all people doing small talk. If you're developers, you know that means they were basically crazy far end of the object-oriented folks, people who eat, breathe, and sleep design in terms of how to do best approaches. But not only were they small talk folks, they were patterns folks. Kent Beck is now famous for having built extreme programming and test-driven development. Before then, he was famous for having written a small talk patterns book. What's patterns say? Patterns says, let's do what we know works. Before we go out and try crazy solutions and discovering new things, let's take a look at, we know some things work, let's take seriously using the things that we know work. So XP basically said, what do we know about software process? Can we do a patterns mindset on software process? If we know this approach to programming works, do it. If we know it doesn't work, stop doing it. And that's what XP is. The original first edition, which I personally like better than second edition, vision of XP practices is pair programming, the planning, game, test-driven development, whole team, continuous integration, refactoring, small releases, coding standards, collective code ownership, simple design, system metaphor, and sustainable pace. That's what XP comes out and says as the goals. We can go through all of those fairly quickly and say what each one of them are, but essentially, I want to just go through one of them to begin with to say, here's how XP thinks. So, if you're a developer and you run into a problem, how do you solve the problem? If I'm a developer, right, and I write code still on a mostly daily basis. If I'm a developer and I write code, and I get stuck, the first thing I do these days is I Google Stack Overflow, right? Everybody Googles Stack Overflow, or Googles, and it takes you, the first result is to Stack Overflow, so same thing. So we run a Google search on the problem we're having, and half, 3/4 of the time, Google search on the problem we're having solves my problem. Okay, so suppose it doesn't solve the problem. What do we do next? Well, as a programmer, the next thing I do is I run this through a debugger and I step through the code and I watch what's going on with the variables as the code executes. And half or 3/4 of the time, that solves the problem too. And so now I'm dealing with the rest of the time. If I've already failed to solve via debugger, and reading the logs, and have already failed via Stack Overflow, every person who has ever written code in production has solved the how do you look next at the problem the same way. You call over your friend. Every person who's ever written code has done this. So you call over your friend sits down with you, and you go through and you fix the code together. This is how you actually solve problems, and all programmers know this. Before you had Stack Overflow, you did this a lot sooner. Before you had a very nice, easy-to-use debugger, you did it even sooner. But you call your buddy over, you sit down together, you write code together. If you're lucky, your buddy walks past you, says you missed a semicolon, you get angry, and you're done. But some of the time it's harder, and so you sit down together and you work through it. The fact is, if you write code with your buddy, almost all of the time, you're getting it done faster, you're getting stuck less, you're making fewer mistakes, the code is better designed, and most of us already know that. So extreme programming asks us a simple question. Why do we allow programmers to write code by themselves if we already know that paired programming solves effectively all of the programming problems that we have better than individual programming does? Fear of how much it costs? Yes, that's a big part of it. But extreme programming says, let's actually do what we know works, which is when you write code, pair. Essentially, the other extreme programming method problems, techniques, practices are all of that form. What do we already know works, but nobody's actually doing? Why don't we just do the things that we already know works? And so you end up with a list of extreme programming practices, and I can talk about those for days and why they work. I just wanted to look at pair programming because it's really coming from an experiential point of view. It's not a theoretical point of view. It's, as programmers, we know what has worked. This works, and it works far better than other choices. So let's do it. On top of this, we found that when doing all of these practices rather than just one of them, they feed off of each other. For instance, test-driven development is a great technique, but I can't actually do it successfully by myself, despite 20 years of trying. However, paired programming allows test-driven development to happen. Similarly, coding standards are nice, but when we have individual development, they tend not always to be followed. When we have collective code ownership, it's easier to follow coding standards. These practices are not really separable. They actually fit together nicely in a way so that doing pair programming is a nice benefit. Doing test-driven development is a nice benefit. Doing pair programming and test-driven development together is not 1 + 1 is 2, it's 1 + 1 is 3. There's multiplicative effects. Yes, I know 1 × 1 doesn't make anything, but there's multiplicative effects, there's synergies. It's a big deal to do lots of these things. And it's about what the developer does mostly on a minute-by-minute basis throughout the day. Practice is centric. The theory is do what works, don't do what doesn't work. XP has a list of principles and a list of values, but that's not where it came from. Where it came from is what actually works historically. There's a second edition. I find the first edition easier to understand. So, Kyle, why are you a technical agilist? Great question. I'm glad you asked. Fundamentally, this is my topic. This is why I'm a technical agile guy. It's been the topic I talk about for the last 17 years. I've actually been talking about it for 20 before I discovered XP. It's just XP finally gave me a solution. I was at an insurance company once upon a time. I've worked at a couple insurance companies. So I was at an insurance company. And when I worked at the insurance company, they said, hey, we're going to add a rate code. That's going to be a project. And I said, how much does that cost? So I went through and I sketched out an architecture. Hey, you've got your user interface, and so we're going to have to update a field on the screen in our user interface, and then I'm going to have to update the controller a little bit, but not very much. And we're going to have to update our service component, and that's going to make a web service call probably to a RESTful service, and that RESTful service is going to call a data access layer, and that data access layer is going to call a table in the system, and so we have to make some updates. I think I can do that project by myself with a test person, with a tester, for about 2 weeks, 10K. That's about the spend you would have, right? I figure anybody else with 10, 15 years of Java experience can do the same thing. Okay, so I think it should take about 10K. 2 weeks later, they came back saying, I got a team of 5, 13 weeks, it's going to take $250,000. Okay, so maybe I'm stupid, right? That's what I'm thinking. Maybe I just don't understand software development these days. Maybe I've forgotten stuff. Maybe my estimate of 10K is 100% unreasonable, and it's far harder than I think. So I went to my friends in Silicon Valley. And I said, hey, Silicon Valley, you're an advertising company, like every firm in Silicon Valley is an advertising company. You're an advertising company, and you do work in 218 countries, so you've got an absurdly complex regulatory environment. Can you do a discount? Can you do a 3.14% discount for ads on Pi Day? They said, sure, we can do it. Not only did we do it, we did it. How long did it take you? Yeah, I personally did it in an hour. Let's take a serious look at this. If you look at this, an insurance company trying to add a rate code into their system took $250,000 and a quarter of time. A Silicon Valley company did the same task on a different software system for $250 worth in stock options. One guy 1 hour. That is a full 1000x in cost and time difference between the two different approaches. If it is possible that two different systems as designed can lead to 1000x differences in the costs of making a small change, I don't know how it's responsible in software to talk about anything else really ever. My experience says that. By the way, I talked to the Silicon Valley company that was taking an hour, and a guy, and told him that, hey, I'm telling this story about you. He said, really? Gosh, I'm embarrassed. There's no way that should take us an hour. Come on, that's silly, right? People aren't even, I mean, no, but he said, no, really. So I fixed it. And it now takes 15 minutes to make that change, of which 15 minutes is, it takes 15 minutes of my time and 15 minutes of automated deployment. And then, honestly, I talked to them yesterday evening, and they said they'd cut it in half again. And so really it takes 15 minutes of his time, and then it's about 5 to 7 minutes to actually deploy the thing. Okay, so this is some crazy guy in a webinar saying some software is 1,000 times as much expensive to maintain. That's 3 orders of magnitude. That's barely believable. Right? Actually, it's well past believable. You shouldn't believe strange people telling you things like that. So I went out and did some research myself. Turns out the guy who founded Scrum, and I always forget which one of them it is, it's Schwaber or Sutherland, he also writes on this topic. And his published research paper on the topic says, when he did a study of different software projects across different organizations, he found that between the strongest project he found in like 99 and the weakest project he found in 99-ish, the delta on productivity was 2000x. So I'm not alone. I'm not the only one pointing out that really there's 1000x productivity differences available in software depending on how you wrote the stuff. If that's true and you're not chasing those things, it's got to be one of two reasons. Either you don't know about them, or you don't believe the folks telling you that they exist. Because if you believe they exist, then I can't see anything else in software that matters that much. So my framing is that the core question as a software developer is, how much does it cost and time to make a skip, a small correct change in production? How much does it take time? How much does it take money? What's the impact on future changes? When I say correct, what's the percentage of times they're not correct? How small are they? These are questions that I ask, but the core question is, one small correct change in production, what's it cost you? We know that there's organizations at which one small correct change in production costs them less than an hour, less than a couple $100 on average. And that matters. Okay, so the question is, how do you actually move towards having a good skip? Well, as Ken Beck pointed out early, when you make a change to your software, you can either make the change to your software, and then that makes the next change a little harder. Or you can make a change to your software, and then you can take the time right now to decrease the cost of future changes. Those appear to me to be almost the only two choices. Either you make a change and it increases all future change costs, or you make a change and when you make the change, you then take further time to clean up your code so that future changes don't cost more. Pick an approach, one or the other. There's not really very much in between. The extreme programming answer, the core trick in XP is every time you make a change to your software, you have to refactor the code again and update the micro level design for every single change you make to your software. Some of us started off doing that naturally and didn't stop doing it till our managers yelled at us too much. Some of us get away with it even now, but it's not the normal approach done these days. So, what's refactoring? Refactoring means update the code to be better, probably better, easier to maintain, while preserving the same functionality. Unfortunately, it's dramatically different than anything else you could be doing. If every single time you write code, you then go back, check the design that currently exists, and change it based on what we've now found based on the new requirement, and you do that as a habitual behavior, that turns everything we've done historically about code upside down. What about the scary modules? Everybody has one. Some code is too hard to touch. Nobody wants to touch it. You might break it. Yes, I agree. There's code like that. It is scary. I've met that code. I can frequently name routines from prior organizations I've worked at that we're afraid of. But at some point we have to touch this because that's what refactoring is about. How do you do coding safely? Well, here's the best understanding of XP I've put together. XP is the question of how do you do refactoring safely. To refactor safely, you have to have extreme levels of testing, test-driven development. You have to have extreme levels of code review, which is pairing. You have to have extreme release speed, which is continuous integration in small releases. You have to have programmers who are alert. We know that 40 hours came from Henry Ford maximizing the productivity of his assembly line workers, right? If Henry Ford maximized assembly line workers' productivity at 40 hours a week, I don't think programmers actually have that much mental bandwidth to do programming. My experience is if you're asking programmers to program more than 25 to 30 hours a week, their brains get pretty full and it ends up being pretty tricky, particularly if you're doing paired TDD, which is exceptionally hard intellectually. There's also the business of extreme knowledge sharing so that one person leaving the team doesn't kill your team. There's also the business of getting clear requirements. If you want the ability to do refactoring, you need to have all of this stuff. And extreme programming has basically codified that into 12 practices, all of which is a way of supporting refactoring, which is basically a way of trying to push the cost of making a change to your software closer to the $250 in an hour for a small change to software to be deployed to production, rather than $250,000 and a quarter for a small change to your code to be deployed to production on average. Of course, blah, 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 averages. I'm not talking about one thing. Every organization has a couple superheroes who can go make a quick change to the code, push it, not test it, and it will work. And so everybody can do that a couple times. But you can't do it reliably. The question is, what can you do reliably and regularly and each time? And if you're not close to the $250 hour to a day from requirement to it's in production, then we got to talk about not having agility working yet. XP, as Kyle understands it, is refactoring. How do you build changeable code? Well, you change your code every time you touch it, and you make it easier to change every time you touch it. XP is refactoring plus the practices that make it easy to do refactoring. Okay, so I've now got what extreme programming is. There's a couple other topics in the engineering portion of the class. I count myself as having about 18 or 20 minutes left in this section. If you have questions, I do watch the screen for questions. I've seen a couple and answered a couple, but okay, somebody just said they wanted to, somebody put their hand up maybe? No, they put their hand back down. Okay. You can write the question if you want, or you can ask it and I'll see if I can find you. I was going to move on to unit testing. So when I do this class for an audience who's actually taking the class rather than taking the overview, that part that we just did takes part or much of the morning. We do a lot of getting to understand these things rather than seeing them as we run past. And then we go into unit testing. Unit testing is the first thing you need to understand if you're going to do extreme programming types of stuff. You need to understand what unit tests are and specifically what they aren't. Real quick here. What aren't unit tests? Unit tests are ways of testing units in your code. I have walked into organizations, though, and said, hey, do you do unit testing here? And they say, yeah, of course we do. We do unit tests. And I say, how many tests do you have on your application? They say, I've heard the number, and this is honest to goodness number, 8. 8 unit tests on your application. You have 8? Yeah, we have 8. It's great. We run them every week. At some point, you have to realize that not everybody who says unit test means the same thing by unit test. And in fact, 90% of the people I walk into talking with them about unit tests, and I'm saying, here's what we need. We need unit tests. They say we have unit tests, but they don't know, they don't mean the same thing I do. So what's a unit test? Is a unit test a test of your system? Is a unit test an automated test of your system? Is it an automated system tests? Is it automated custom unit tests? Or is it automated library supported unit tests? Or is it test-driven development? Because those are 5 different kinds of things that people call unit tests. And it's fascinating to watch the differences. Some people talk about system testing. And hey, if your developers ran a system test, we call it a unit test. Right? This is the kind of English script we'd have, and then we'd execute the script. And if the developers execute the script, some managers call that a unit test. This is a true story. I've been there. I've seen that. System testing is great. It tests correctness and ease of setup. I'm going to jump forward some of this because I don't really have time for all of that. If you are doing automated unit testing, if, for instance, let me see if I have the code. Nope. Okay. If you're doing automated unit testing, that means that we are writing code for individual functions, basically. It's not really for functions. If you're in JavaScript, it's for functions. If you're in Java, it's for, or .NET or something like that, it's for classes. But you're writing tests for individual classes. You're running them independently. The core value that the core value that we're getting out of unit tests is they're a regression test suite. Some managers mistakenly believe that unit tests primarily exist to test correctness when something is built, and they are a very low return on your investment if that's what you're using them for. And I'm an enormous fan of unit tests. What unit tests are for is they are for a regression test suite. The purpose of a unit test is every single time you make a change to your application, you rerun the unit tests. If you rerun the unit tests every time you make a change, and you add unit tests, and you change the unit tests that should change, then it becomes incredibly easy to discover if you broke something in your system. Also, it finds out where the break was. It's really powerful. No lying, it costs you something. But automated unit testing is incredibly valuable. It's incredibly important. And it raises the level of what you can do in terms of changing your code to some silly level. It's not all of what you need to do, but it's an enormous step forward in the direction of just getting code working correctly. Most experts think of automated unit tests with a library like JUnit or NUnit or PyUnit or Jasmine or something like that as being what unit testing is. And it's about what happens after you change the code. It is not about initial correctness value. Okay? This is a part that seems to not be understood by anybody. If you are near the end of the project and you're running a project and somebody says, let's add unit tests so that we're sure we're right, that's almost zero value to your project. It is huge value to the product after your project ends, but it is very low value to your project until you make the next set of changes. All of the value of unit testing is about what happens after you finish a chunk of work and then you come back to make changes because the requirements changed again. Test-driven development is another level. So there's a question, and I want to address this. Is there big value in writing unit tests early? I'm a test-driven development guy. I prefer writing tests early. I actually don't like going into dynamically typed languages like Python and JavaScript and Ruby and Groovy until people already understand TDD, test-driven development, and write their code that way. That said, most of the value of unit tests, 90% solid of the value of unit tests is in a regression test suite. If you've got a 3-month project, I bet I can do the project cheaper by writing unit tests with every bit of code I write than I can without doing that. Yes, I will write twice as much code as you were thinking, but I will find my bugs so much faster that the trade-off is there. And I agree on the dynamic languages thing to some extent as well. But an enormous amount of the value comes down to regression testing. Test-driven development. There's a question, which framework and API is better for unit testing? That's seriously dependent on which language you're working in. JUnit is seriously standard in Java. Jasmine is used most frequently probably in JavaScript. There doesn't appear to be a standard in .NET. There seems to be too many different things. I'm used to PyUnit, PyUnit in Python. Varies by language. I have a mild fondness in JavaScript if you're doing node development to use Mocha Chai Sign-On rather than Jasmine. You got to talk to me about languages. I got a vote from the class saying PyTest is good as well, so it's not just me. Those are my basic answers. If you're picking a different language, we have to talk about it, but those tend to be the industry answers that are most commonly used. Java, people start with JUnit, and then the mocking frameworks vary substantially, but it doesn't matter too much. They all do the same thing. Okay. So the expanded version of this course, of course, I teach people to do this stuff instead of just telling you about it. I do need to say something further about test-driven development. Test-driven development is fundamentally not really a method of doing testing. Test-driven development is understood by almost the whole world to be write your test, then write your code, and that's what test-driven development is. Test first doesn't even scratch the surface of what TDD actually is and what it matters for. What TDD is my definition. This is Kyle's definition. I wrote a book on the use of ceremony in business, so I'm using that on purpose. TDD is a method of doing software development that uses a ceremonial approach to writing unit tests with your code in order to improve the design of your code. Fundamentally, TDD is a way to improve the design of your code. It improves the design of your code by following a structured, fairly ceremonial, rigorous, you can almost do it to a drum beat, way of writing code, and it does software development. The core of TDD is TDD says red, then green, then refactor. The primary goal of TDD is that every 5 to 10 minutes through your development day, you have room to refactor your code into better design. That's what TDD is. It's a method of making sure that every time you touch your code, you spend time paying attention to and probably doing refactoring. That's fundamentally a design goal. Make your code better designed at the micro design level, mostly, but also refactor larger chunks. Create a habit of making changes to your code. Force yourself into a system where the code is being designed to be easy to be changed. TDD also does a whole bunch of value in terms of preventing you from being stuck. TDD always has an answer for how do you get better at being stuck. By the way, TDD also makes your unit tests better. I believe that was the original goal of TDD, but none of those are why I do TDD. TDD is about these things. Better unit tests and that your unit tests need to run fast, yeah, those are important. But the top there is where it's really about. Mostly it's about room for refactoring. It's a very, very big deal. TDD says red, green, refactor. The most important thing is not the test first. The most important thing in TDD is that you do a refactor every time you change your code. I'm jumping forward a little bit because We're short. The most common words you will hear around TDD are red, green, refactor. Write a test, run the test, confirm that it fails. Write the code, run the code, confirm that the test passes, then check to see if we need to change the design of the code that we've written or the code near it. And if we do the refactor. That's what TDD is. It's very poorly understood. I don't know that I've heard it said anywhere, and this includes Kent Beck and Martin Fowler and Bob Martin, that TDD is basically a refactoring tool. All of them know this. All of them will admit it if pushed on this. But it's not said clearly in any of the materials, and so I find it's really important to say this. First, we make sure that we refactor. Second, we make sure that we run our code test and refactor cycle in short cycles. Like it's 15 minutes maybe when you're learning between starting a cycle and getting to a refactor point. 15 minutes, red, green, refactor. Maybe 10, maybe 5. Doing your test before your code is a nice benefit, but it's not that important. I have some other ways of explaining this. I'm not really going to go here. This is an explanation of red, green, refactor, what that means. This is the detailed level. At one point I made this as a joke and wrote it in code. But this is basically the same thing. What does red, green, refactor mean? TDD has a bunch of trade-offs. The core issue is I am spending time today trading off against time tomorrow. If you do this for 3 months, my experience says you are a net winner on time. I also find that it's almost impossible for me to do TDD effectively by myself. I have to pair to do TDD well. I also find that in a lot of people looking at initial correctness checking, they want to talk about unit testing in TDD, and that's just not what it's built for, right? It is built for systems where we're changing our mind fairly frequently. That's what it was created to do. I'm basically done with this section. I'm basically on time. I've got 5 minutes and I'm going to finish my 5 minutes, and then we'll take a 10-minute break, come back and talk about the next piece. If you're going to do serious unit testing, you have to study mocking. Unit testing in the modern world doesn't work without mocking. Basically, if you have, if you have code that looks like this, and I wrote this code in JavaScript, if you have code that looks like this, var a equals function on x, return call function b, x plus 1 minus 1, how do we test a? Because if I test A, it's going to test B. The core question in when you're doing good unit testing is how do I limit this so that I'm testing whether A does what it is supposed to do, and I'm not testing B. If A works and B doesn't work, we can't tell by testing A. It takes some amount of work to provide a fake implementation of B so that I can test A without also testing B. It's a very important part of testing, and there's a bunch of disputes over exactly how to use mocking. If you have time, read Martin Fowler on mocking. He's got some interesting things to say. But the core problem is unit testing is great so long as you're testing B, which is a function that works by itself. When you have A, which is a function that uses other functions, then it gets a lot harder, and you have to use mocking. And so there's a whole bunch of complicated stuff on, there's different types of test doubles between dummies and fakes and stubs and mocks and spies. The fact is, nobody actually ever uses these words in real life. They use the word mock for all of them. But there are 5 different theories of what we're trying to do here. And if you're going to do unit testing seriously, you have to do test doubles. And mostly, you have to understand what mocking is about. The basics in Jasmine, the JavaScript testing framework, are everything starts out as basically a spy, and then you have to figure out how to apply these approaches to testing off of a spy. My final thing I wanted to mention is a discussion of refactoring. The core purpose of TDD, indeed the entire purpose of extreme programming, is to allow effective refactoring. How do you make quick changes to your code as you're going along? Short answer, you make changes to your code as you go along by first setting up stuff so that you can, and then figuring out what kinds of changes you need to make. There is a canonical work on the topic. It's called Refactoring. We've already said that both Kyle and the founders of Scrum have found that different systems can, one system can be 1,000 times more costly to change than the other one. So what we need to do is make changing our code easier. And the right solution is every time you make a change to your code, check for refactoring. Lots of ways to say what makes good code. This is my personal model. Don't repeat yourself, understandable, small pieces, and tested. DUST is my acronym for what makes good code. I see very rarely code that fails one of these that I would call good. And I very rarely see code that passes all 4 of these that I would call bad. So that's my easiest understanding of good code. Basically, the goal of good code is making your code maintainable. Performance is nice, but performance is bottlenecks. Don't go for performance first. And the book on refactoring is called Refactoring by Martin Fowler. If you have 15 years of experience in software, you look in code and you go, that one feels wrong. Or in Martin Fowler's words, that one smells wrong. There's something wrong with the code. The refactoring book is a couple chapters on what code smelling wrong is like, what you should do about code smelling wrong, and then it's a catalog of code smells and how to go about solving them. I think that is what I needed to say about Agile engineering. Agile quality is next, but I've just talked for an hour and nobody likes to listen to somebody else yammer on for 2.5 hours straight. So why don't we take 10 minutes, come back at 25 after. I don't know what time zone you're on, so come back at 25 after the hour, and we will continue on with Agile, Agile quality. I am paused for the next few minutes. I'm going to take like 2 minutes, stand up, stretch, sit back down, and I can answer questions in the meantime if anybody comes back before the end. I'm paused. Okay, I am back. I am assuming many of us who are here are back, and we can move on to the Agile quality section. In the first half of this class, we talked about basically engineering practices. We talked about what kind of scope of a problem Agile technical practices are trying to solve, and I made a claim that matches that of the founders of Scrum, that there are 1000x differences in the cost of making a small change between organization A and organization B, between product A and product B. I've looked at 2 products doing the same thing in the same organization, roughly, with basically maintained by the same team, and seen 100x differences. If I have to make a change to this system, it costs me 100x in time and money that it does to make the same change in this other system. So we try and do as many of our changes in this other system as we can. That's not the whole picture, though. That's the engineering part of the picture. That's where a lot of this stuff started. The software craftsmanship folks and the XP folks spend much or maybe most of their time talking about that side of the technical Agile space. But there's at least 2 other sides of the technical Agile space. One of the other sides of technical Agile is you have to go ahead and you have to make sure that your builds are done right? Environment management, scheduling of builds, kicking off of builds when we need. Hey, where do we do development? What's our branching strategy? Those kinds of topics. Stuff that has a lot to do with build and somewhat less to do with how an individual developer spends their minutes writing code. That area is currently thought of by a lot of people as being DevOps, and I basically that's how I refer to that area as DevOps. Properly, that's not fair. DevOps is more than CI/CD, but given that I am a XP guy, distinguishing DevOps from XP, I have to make up some sort of line, and the CI/CD stuff is what I think of as DevOps as different from extreme programming. So there's the build and deploy and related, and then there's the quality stuff. So if you go and you have a clean extreme programming team building really good software, and then you go to your director of quality or whatever you call them at your organization and say, okay, we'd like to bypass your traditional testing techniques and just deploy straight to production. Most directors of quality laugh at you at that point, and they say, I have no reason to actually believe you that you should be allowed to deploy directly to production. And so pretty soon, if you have the conversation honestly, what you get to is you can do Agile in your team all you want, but I've got Sarbanes-Oxley rules, and I have NAIC MAR rules if you're in insurance, and I have Rule X and Rule Y and Rule Z, and everybody cares that I am checking quality. And if I let quality go out, and if I let you deploy, and you can't demonstrate quality to me, I shouldn't let you deploy. And so no, you might be able to do your code in a couple minutes, but we're still going to spend our 4 weeks necessary to do our testing. And if they're going to spend 4 weeks to do testing and verification, and you can deploy small bits in 8 hours, what value is it that you can deploy small bits in 8 hours if they're going to take 4 weeks to let you deploy? Well, that's a good question. So what should you do at that point? What you should do is you should say, hey, Director of Quality, that makes a great deal of sense. I agree with you. You shouldn't let us deploy until we can show that our quality process produces better code, better quality than your quality process does. If we can build a quality process on our team that as a process has a lower defect rate than what you're seeing from traditional testing, then and only then should you let us deploy to production based on validating our deployment process rather than running your default process. I don't want a quality organization to let me write Agile and write unit tests and deploy directly to production. I want the quality group in my organization to approve my process at the point that my process does enough testing, enough quality checks, at the point at which my process does a better result of quality than the traditional manual testing process. That's what Agile quality is trying to do. We can do better quality in an Agile fashion than we can historically, and it's just a matter of learning how to do that. So, what does Agile quality consist of? Agile quality, and you should see the screens change now, consists of basically automated quality. If I talk about Agile, I'm talking about what's the cost, what's the time, what's the speed, what's the change cost of making a small correct change in production. If that's what I'm talking about, any manual steps at all are incredibly costly. If it takes a manual step between push the button to say deploy and a manual approval needs to happen before it deploys, the cost has gone from I can get this reliably done in a couple hours to I hope it'll be fixable in a couple days. We're talking 20 times the amount of time. We're moving skip costs from hours to days, and that's frankly unacceptable in an Agile world. We can't afford the kind of delays that you can afford if what you're doing is running off of a coordination theory rather than running off of a change theory. In Agile, you must have the ability to do fast turnaround. In code, if you can do fast turnaround, you are probably either hiring superhero developers like they do in Silicon Valley, or you're running some variant on extreme programming, software craftsmanship stuff. If then you want automated deploy, you have to get automated quality up to snuff so that the test groups can trust our deploys. So what kinds of automated quality do you want to be able to deal with? You need to be able to deal with the build and deploy pipeline stuff like Circle CI and Jenkins and stuff. You need to address the quality of your code from a static code analysis standpoint. You need to be able to test your tests, and most test coverage tools aren't very good. You need to be able to do web testing in an automated fashion. You need to be able to do service testing in an automated fashion. None of us deploy single monolithic apps anymore. It's all microservice world, small pieces and RESTful APIs and such. You also want the ability to deal with behavior-driven development. And there's a number of other testing topics too. Load testing, visual diffs, etc. There's also the question of DevOps and what we should be talking about there. I'm not really going to go into that. I consider that a different topic, but we can at least wave at it near the end of the course. So my goal here is I've got about another hour. Wait, hold on. This class, right now, I have about 55 minutes left in the class is what I remember, right? I got myself confused for a minute there. Yeah, 52 according to my clock. Okay, I haven't heard anything back from anybody since I started the second section. Can somebody say, yes, we're seeing your screen, and yes, we're hearing you? Okay, somebody raised their hand. That was good. Thank you. I appreciate that. Okay, so basically, I've got an hour to do an intro to these topics. That doesn't give very much time for each one of the topics, but we're going to do a decent intro. Traditional quality. Probably, so at various points in my career, I've basically had the job of, hey, Kyle, what should we do about this? Go out and learn it, research it. And so one of the things I spent a lot of time researching was, hey, what's the actual value of unit testing? One of the things we found out really quickly in studying testing was it is more or less true of testing that every individual type of testing you add decreases the amount of bugs remaining in the software by 20 to 50%. Some methods, requirements testing, remove 20 or 30% of the bugs. Some approaches to testing, system testing or unit testing tend to remove something closer to 50% of the remaining bugs. On average, every type of testing you add removes some percentage of the remaining bugs. That percentage is almost 100% of the time between a fifth and a half. So the correct answer, if you are chasing high levels of quality in a traditional environment, is do more kinds of testing. The classic example of this is, of course, NASA and their space shuttle code, which has huge numbers of layers of testing on it. We write the requirements, and then we do substantial amount of review and testing of the requirements to confirm that the requirements are correct. We do an analysis phase, and then we do heavy-duty testing of the analysis that's been done. We do a design. We test the design in various ways, mostly manually, and every step along the way, we do a step and we do testing on it. If you can stack 10 or 12 different levels of testing onto something, even if each type of testing only provides 40% value, that's an enormous amount of bug removal. Only one bug in, yeah, I'm sorry, I'm not doing the math fast enough. You get to a real close to 6 Sigma level of quality by doing a dozen different kinds of testing and catching of bugs as they go along. However, Agile has a different point of view. Agile's point of view is the core metric in what makes software good, the core metric that we care about in software, is a small correct change in production. What's the cost? What's the time cost? What's the dollar cost? And etc. So doing a dozen different kinds of testing is great, but it's more or less incompatible with traditional quality approaches. Traditional quality takes time, and Agile doesn't have time to take. So what can you do? Agile's quality question becomes, how do you do quality at velocity? How do you do quality quickly? And that basically comes down to several pieces. One, I have to do fast development, right? Interesting point on fast development. I always in Agile keep coming back to the point that I need to say fast development, but I need to say fast development in the long term. I don't care if my first week is fast development or not. What I care about is that the total amount of time I am spending developing stuff drops. And so if I'm doing fast development on week 1, but it's making my development slower on week 6, that's a bad deal. If I'm doing fast development if I'm doing slow development on week 1 though, and it helps to speed me up for week 6, I usually like to make that trade. I'm usually trading time now for trading time later. I spend a lot of time these days in my Agile discussions talking about how we are really always thinking in the long term, since Agile thinks in terms of team and product rather than in terms of projects most of the time. What we're really talking about in Agile is how do you maximize the productivity of a team for the long term. Just like if you're running a sprint, you want to get Usain Bolt to run the sprint for you, but Usain Bolt might not be your best choice if you're running a marathon, right? You should get one of those Kenyan guys who win the Boston Marathon every year, Joffrey, whatever his name is. And so the time frame that we are paying attention to is enormously important to discuss. And we're usually not discussing it enough. So when I say fast development, I mean fast development when we're doing that, and usually late in the product lifecycle. I want to maximize the speed of development, not usually maximize day 1's speed of development, but maximize the development speed at some point later in the product. Maybe I want to maximize total productivity across the first 5 years, right? I like to discuss that and admit it explicitly. I don't hear it talked about enough, the long-term versus short-term trade-off there. So Agile pushes a model of making the long-term versus short-term trade-off explicit in terms of quality, in terms of development speed. We also want to do the same kind of thing in terms of how integration works, right? I can do my first integration really fast, but if I want to do my 100th integration quickly, I need to spend a reasonable amount of time working on integration approaches and improving my build pipeline. Similarly, I need tests to run quickly, and I need to be able to deploy quickly. Those are the kinds of topics that Agile needs to work, and if you add most of that up, I'm sorry. So the reason I wasn't running like this is because there's some stupid automated timing in here that I don't like, and it was getting in my way. There was a great answer. There was a great question that just came up here that I want to take a moment to answer. Startups tend to push for let's not take time now in order to save time later. So my short answer is I am very happy to not take time now. The core question, the core difficulty is a startup world is operating off of a specific set of financial constraints, like can we get enough funding to keep going? That's our primary problem in a startup world. And so a lot of the time it is worth millions of dollars to a startup to have something delivered today rather than tomorrow, right? It's actual millions of dollars for a day of difference in delivery time. My solution to that comes down to, and I do this sometimes even in larger organizations, delivering something today is worth a whole lot and waiting until tomorrow isn't good enough. My normal line is, I am very happy to build you code for today. But the moment you ask me to change the code, I am going to burn the code that exists and write it correctly, which will be slower. You cannot simultaneously optimize for today and for a month from now. If you optimize for today, then when you get to a month from now, your total time will have been slower. Similarly, if you optimize for a month from now, your total time when you get to 2 years from now will have been slower. Your total delivery. So you really have to pick an optimization time. If you choose to optimize for today, my strong recommendation is that you write, this is prototype code. If anybody touches it to change it, rewrite it from scratch. That's my standard answer. I have done that exactly in large organizations. We have code, you need it tomorrow, fine. I'll write the code for delivery today. It's not going to be code written correctly, it's going to be code that will run today. But at the moment that you ask me to change the code rather than to just have a prototype up, then I'm going to take the time to write my code into changeable states. So I distinguish heavily between prototype code and code that is production changeable code. And that has done well for me so far. Yes, it takes a huge amount of discipline to not let the prototype become the application. And so I said, very specifically, as soon as you make one change to the prototype, as soon as they ask for change, you burn it. And that's exactly what we've done, and it has worked well. Yes, it takes discipline, but all of this takes discipline. TDD is one of the most disciplined approaches to coding I've ever seen. So I'm going to continue on. That's my answer. I have personally seen it work. I have done that, and intelligent customers have appreciated that approach. We need something today, and then you're allowed to fix it, so that it's cheaper for us tomorrow too, right? We'll burn a day to make a fix today so that we can have a demo. Okay. So, let's pop through a few of these things. In traditional build and deployment, what happens is the build engineer is the role, and we do a set of things like this. The developers write the code, they deploy locally, maybe to development, maybe to test. The developers check in their code to source management. They say, we think we're ready to build. See, that's why I haven't been doing it this way. Sorry, I'm doing it this way because I'm not smart enough to turn the automated timer off. The developers write the code, the manager gets the deployment approval. The build engineer then checks code out of source code management. They manually build to a higher environment. The testers test in some higher environment. We get further approvals, and then the build engineer manually deploys to the next environment, and we do more testing. This is the standard model. That's the model I was running in for years and years and years. Not the model I wanted to run in, but there's an awful lot of large application development shops where that's the kind of thing that we do. In the Agile process, we can't afford that. We honestly need one button to deploy to an environment. And if we're really cool, we need one button to deploy the code to somewhere. And if the best case scenario is we one button deploy, we do the automated testing, and we generate an environment. The old school Agile pipeline is Hudson or Jenkins. It was a web application. It's very much like cron, which is the Unix scheduling tool. And the typical usage is I have my Jenkins job, which I build on the Jenkins server. I link it to a build script, which is a Maven build script or Gradle or Ant. And what this does is it kicks off, downloads the code, runs the build script in Jenkins, takes the Jenkins build script, runs the Maven or Gradle or Ant, I'm sorry, this is coming from a Java world, runs the build script there, generates a jar file, places the jar file somewhere into some sort of test environment, runs the automated tests, and then takes and deploys that resulting code to a further environment, maybe as far as production. Jenkins is set up in some sort of master-slave format. You have a bunch of existing slave machines set up fairly identically so that we can run our build process on whichever slave machine happens to be available today. We have also the ability to stop this. If our tests fail, we stop those. And more or less, Jenkins is calling a bunch of command line tools. Modern theory of build deploy says that old Jenkins, Jenkins 1, Hudson stuff isn't good enough. If you have Jenkins 1, then you've got your build script living with Jenkins instead of with your code, and that's a failure of modularity. your build script should live with your code. And so all of the modern build systems, from Circle CI to Travis to Jenkins 2, they are basically a script executing engine when some event happens, either timed or triggered or something. Then they go to a specific location in code. Most of the time that's get. They download the code from get, and then they run a script at some specific location in the code that they've downloaded. In general, there's a whole bunch of tooling involved with these modern build processes. You don't do a modern build process with just Jenkins. You're doing Jenkins plus a boatload of automated testing tools. You also don't tend to deploy straight to existing environments. Existing environments is not a terribly effective way of doing deployments, mostly because an existing environment frequently gets changed. I've been working with some folks these days at a company I consult with who are running a 9-month project, and as far as I can tell, they're like 4 months behind because of environment management issues. In the modern world, if you are doing Agile-ish stuff, you have to be doing environment provisioning. You have to do virtualization. You have to do containerization. If you're not doing that, you don't get then your environment issues eat your whole deployment. The first time I went in to do to set up the build scripts at one of the more recent organizations I was at, I honest to goodness spent 2 solid weeks fighting with their Jenkins 1 system because they did not have stable environments. They had worse than that, they didn't even know what was on their environment. So slave 1 looked one way, and slave 2 of the Jenkins system looked an entirely different way. So that when I'm saying, hey, I would like to I would like to run this build runs fine on slave 1, build runs fine on master, build fails completely on slave 2. What happens is that having scripted environment structure so that you don't have to figure out what's in your environment and what's not in your environment, that you build it each time, turns out to be it's no longer an optional approach if you're doing relatively complex builds. It's mandatory. You have to do that, or it just doesn't work very well. On top of all of that, there's also the question of how do we go about doing deployment, and these days everybody has some form of web traffic control. I'm sorry, my words are failing me for a moment. I've been talking for a couple hours. We have some sort of load balancer sitting in front of our web traffic. So web traffic comes in, and our load balancer directs some of the traffic here and some of the traffic there and some of the traffic to the third system. Modern systems, what we tend to do is we will spin up a new environment, hook it up to the correct level, maybe production level of services, and then switch part of the traffic over to the new system. Once you switch part of the traffic over to the new system, then we can find out if the new system is working as expected in production. And once we have some of the traffic there, we can further switch over so that more of the traffic is there. That's generally referred to these days as blue-green deployment, where you have you deploy to a provisioned environment, then you move part of your network traffic to the provisioned environment, and then if something's wrong, once you are doing this, you just remove it from the load balancer, and now it's a very, very easy rollback. That's the model we tend to be talking about these days. Blue-green canary deployments are fancier. The Silicon Valley firms tend to do things like, hey, we're going to deploy this to 1% of our customers, and we will have an automated process whereby that 1% grows unless we discover problems in an automated fashion, in which case we'll roll it back. Pretty cool stuff. Build, deploy runs that way these days. You have to run virtualized, containerized. Your code, as the DevOps folks have been pushing for the last 10 years almost, your environments have to be scripted environments. You can't actually rely on existing environments to work. You have to script the environments and tear them down afterwards. And so the modern shape of build environments, Jenkins 2, Circle CI, Travis, is you have a master-slave environment, but the slave is almost 100% of the time virtual. These are modern build tools. Most of the other ones tend not to be as serious about the virtualization, containerization, and almost none of the other ones besides those are serious about allowing the build scripting to live with the code. You have to do too much scripting separate from your code, and so you're maintaining repositories in two places, and that's not good. So I can show examples of that, but not going to chase that. I have to show you too many other things quickly. What makes good code? We talked about that a little bit a couple days ago. I use my DUST approach. Don't repeat yourself, understandable code, small bits and tested. The object-oriented people, Craig Larman, has the GRASP acronym. General responsibility assignment software principles. We have best practices, use polymorphism, use dependency injection, use indirection. There's a bunch of general principles of how to do stuff well in the code. You can read Uncle Bob's Clean Code. You can read Steve McConnell's Code Complete. There's lots of ways you can go look. Hey, is 12-factor? Okay, solid. There's so many different people talking about here's how to write good code. We all agree writing good code is a good idea, though. So how much does it matter? Again, I tend to think that at least a reasonable portion, I'm going to be simple and say, let's be generous. Let's split it into 3 parts. Good code is 10x multiplier. Good automated testing is 10x multiplier, and good automated deployment's a 10x multiplier. Okay, so if you do all of those right, you can get your 1000x results that I have seen and that the Scrum founders have seen. Well, fine. So how do you make sure your code is good? Turns out one form of testing if your code is good is manual code review. There's ways of doing this that are less bad than other ways of doing it, but manual code review is something of a problem. If you look, though, what code review is trying to buy you, and this is something I've produced, I haven't seen this written down anywhere else, what is the value of doing a code review? I need to check for correctness. I need to check that the design is good. I need to check that other developers can understand what you did. I need to understand that it's following the team's standards. I need to just have an extra pair of eyes glance at the stuff. And I need the ability for senior developers and architects to put their opinions in. I'm not sure that that last thing is a value, but if you do code reviews, these always happen. So I'm one of the senior developers and architects who puts their opinions in rather than just this is okay and this is not okay. So this is what code review does. But the good news is we can actually solve most of those in various ways. A major part of replacing code review, which is a manual, slow process, is going to involve doing static code analysis. Static code analysis says things like don't write a return statement inside a finally block. Don't have 300 or, as I have seen in the past, 7,000 line functions in Java. How about we limit functions to 20 lines of code, and if it's more than 20 lines, you've done something wrong. Maybe your cyclomatic complexity should be lower than 4. Maybe your function names should be named in our standard fashion. If this is Java, then it's camel case. This type of thing is configurable. There's a bunch of tools that are out there that can do this kind of code analysis. Linting is the standard name of this. Some people call it static code analysis. Other people call it linting after the C tool from the 70s called lint. But it means going through your code and picking out the little bits that aren't good, that shouldn't be there. What are modern linting best practices? Number 1, turn it on. Every organization I have ever been in has linting tools available. Mostly you're using Sonar. Sometimes you're using a JavaScript linting tool like ESLint, right? But JS Hint, some of them. Everybody has the tool. So turn on the tool. Like, actually do it. You take the tool that you have in-house and start using it. Second thing we need to do is we need at least one rule turned on in linting where it will fail the build if you check in code that doesn't pass that rule. I don't need all of the rules turned on. It's desperately important that if you are going to take seriously code quality and moving towards the not 1,000x costs, you have to turn linting on. You have to allow one linting rule to fail your build. You don't have to turn on 2 linting rules. You just have to turn on one to get moving in the direction. The reason people fail to do this is they go in and say, oh, we can't agree on what linting rules to use. Fine, use fewer linting rules. Turn it on, allow the build to fail. It's really important. Use a linting tool and allow the build to fail. Tremendously important. Static code analysis tools. Sonar is the most common one. I have used PMD mostly in the past in Java before Sonar. JavaScript's best liked tool is ESLint, but there's 3 or 4 other ones that are used frequently. There are static code analysis tools like Veracode and Fortify. I've used both of those. I'm not impressed with either of those as being more impressive than Sonar, but the security people like these, so I use them some of the time. Having some form of static code analysis that is done in an automated fashion during your deployment is an incredibly important step to add in. Getting the details right is not as important as adding the step into your build process. Okay, to do it in JavaScript, we can use ESLint, we can use JS Hint. All you basically have to do is configure it to fail. Yes, you can find that there are too many false negatives, so turn off most of the rules. Just turn on one rule. Hey, if I have a function that is larger than 50 lines of code and it's JavaScript, the function sucks and you should fix it. Fail on more than 50 line JavaScript functions. That's a perfectly reasonable thing. Just turn that one on. Once you've accepted that, then turn on another rule. Don't use all of the rules, just turn something on. Yes, if you turn on the standard, whatever it is, 73 rules from Sonar that it starts with, you'll get a huge number of false positives. If you turn on one rule, you don't. And then grow from there. That's the normal fail in linting. I'm moving on from linting. Test quality. So we said, hey, we should do TDD. If you do TDD, probably your tests are good. If you're not doing TDD, then I would bet, and I'm told now that donuts cost $1, so I can't say dollars to donuts anymore, but if you're not doing TDD, most of the time, your tests aren't good enough. But fundamentally, we don't actually know how good our tests are, so we want to measure. What I really want to do is test our tests. If you're testing stuff, there's two ways to do it. We can assume we're good, or we can actually figure it out. We like option 2, particularly if we're testing, because we're already doing option 2. But an awful lot of people do unit tests and then say, oh yeah, we're good. We did unit tests without any real measurement. So there's a bunch of folks who move in and do code coverage. Code coverage says, let's instrument the code, let's execute the tests, let's confirm whether it's hitting the code, gives you detailed reports, it might color code your integrated development environment. I'm used to Emma Jacoco doing this. Color coding, I think we can do that with Cobertura, we can do it with IntelliJ, we can do it with Eclipse. Basically saying, here's the lines that are covered, here's the lines that are not covered. However, there's a problem. Coverage sucks, right? Standard coverage tools aren't actually any good. What they measure is whether a line of code has been executed. They have no comment on whether a line of code has been tested, just whether it's been executed. I have seen a manager tell a group of people, hey, we've only got 30% test coverage. Can you make sure we have 100% test coverage? And their team over the next couple weeks got it up to 100% test coverage. And then a couple weeks later, the manager went in, looked at the tests, and there were no assertions in the tests. So we had tests, all of the tests were failing, we had 100% coverage, and none of the tests were actually testing anything. Coverage provides a lower bound and says your tests are no better than this percentage, but that's the most it can tell you. However, in the past few years, there's a better approach. It's called mutation testing, and here's how it works. What you do is you set up the tool mutation testing. In JavaScript, the tool is named Striker. In Java, the tool is named PyTest, P-I. And you set up the code, you run your tests. If all of the tests pass, then your mutation tester takes your code and changes a plus in your code to a minus in your code, and then runs the tests that touched that code again. If the tests all still pass when a plus in your code was changed to a minus, then we know that you weren't testing that line of code, and your mutation test fails. If, on the other hand, you change a plus to a minus and that changes a test from passing to failing, then you have discovered that you are actually testing that line of code. You have, quote, killed the mutation, and the test actually is you've now got an observation of true test quality. If you are serious about unit testing, coverage tools like Cobertura or Jacoco are nice for giving you good numbers and making you feel good. If you want to know if your tests are any good, use mutation testing tools like PyTest or Stryker. They are an entirely different category of test coverage, and you should use them. Stryker, yes, it's named from the X-Men mutation stuff because it's about mutation testing. Stryker's goal is to see if you kill the mutants. So the good news on the mutation testing is they standardize what kinds of tests they run. So for instance, you can toggle on, go through my entire code base and run all my tests, and then flip pluses to minuses, and if you flip a plus to minus, run the tests that touch that code again and see if they fail. You can also switch on turn greater thans to greater than or equals, or turn remove lines of code so that this line of code that is removed. Those kinds of things, replace a return statement with return null, etc. Go through and test. The mutation coverage is an automated process. It is almost true that all you have to do is turn it on. There are a set of standard mutations. I think both PyTest and Stryker have about 15 standard mutations they apply to your code. Running the mutation test is slow, right? It's nowhere near as quick as a code coverage check, but the amount of information on test quality that you get out of it is absurdly good. I don't even look at coverage I mean, I've been pushing coverage forever, and mutation tools came out in like 06, 07 in Java with Jumble and Jester, but nobody used them, and so everybody forgot about them until just the last couple years. You've seen PyTest and Stryker pop up, and Stryker's still very new. Like it doesn't work with Jasmine on Node. You have to use Mocha if you're using Node. So this is incredibly powerful. People aren't doing it enough. Pay attention. I'm going to move forward. Mutation testing is how you should be doing coverage these days. There's also correctness tests, right? TDD covers design, static code analysis covers quality, mutation testing covers, are my unit tests any good? But one of the reasons we do continuous integration is we know that integration is harder than building small pieces. So how do we test code that's integrated? Well, different names, functional testing, integration testing, system testing, etc. Normally it's done near the end of the project. Normally when other phases run behind, that gets compressed, and it's effectively impossible to keep up with unless you start automating it. So the core Agile principle is automation. Automated web testing comes in record and replay or scripted. In real life, we use some of each. We use record and replay for testers who are transitioning into an automated role, because that's 90% of what we need in Agile systems is automated testing. Record and replay also teaches you a lot about how scripts should look, right? But just like your code should be maintainable, your tests should be maintainable too, and record and replay tests are almost never easy to maintain. And so most folks do record and replay until they learn how to script the stuff, and then they mostly script stuff. The testing tool I'm used to is Selenium. I do most of my work in Selenium, but if you're at a large company, you frequently have purchased some large product like HP Mercury or something that does record and replay style automation testing. Selenium's very nice because it'll deal with whatever language you prefer to work in. And so I have found some sort of tool that can both record and replay and do scripting to be essential to making Agile testing. Of course, managing environments can be incredibly difficult here, but it's nonetheless a big deal. Selenium's great if you're doing web testing. If you're doing green screen testing, it's probably not going to work. It's also not that good for doing service testing, either SOAP testing or RESTful type testing. Testing services is another question that we need to do, and so you should have some sort of tool for testing services. You can do GET requests if you like, manually in the browser, but really most people doing service testing are going to be using some sort of tool. My preference is SOAP UI or Postman. SOAP UI is designed to solve the how do you make SOAP requests and test those. Postman is designed around RESTful service approaches and the mostly JSON nature of RESTful services. And so depending on what your problem is, SOAP UI or Postman is a really powerful tool for testing your services. Postman has a whole bunch of capabilities. It's my personal favorite. I end up managing all of the Postman collections and doing the Postman testing on a recent project. But both Postman and SOAP UI have a bit of a problem. You don't actually want to do most of your testing manually. Even if I wrote 1,000 tests, I don't want to kick them off manually, right? And so Postman has a paired product called Newman, which allows us to download the Postman scripts as JavaScript files, run them from the command line, and basically include them in my build script so that I can do all of the configuration in effectively a record and replay fashion. I can set up a whole bunch of environment variables that can vary by time, and etc., but run this as part of my build script. Doing some form of service testing on top of some sort of web testing is going to be important for an awful lot of applications. Newman, Postman, Newman, or SOAP UI are the relatively free tools that you can use effectively. Each organization probably has some standard API testing tool. I haven't found that most of them are as easy to integrate with them as Postman, Newman, or SOAP UI. Behavior-driven development is another layer of testing. Behavior-driven development, I like to say, first off, this is an entire separate course, 2 or 3 day course on behavior-driven development. I'm not going to do a 2 or 3 day course in the next 10 minutes. Instead, I'm just going to give you an introduction. Basically, the line is, BDD tests the requirements. It makes sure that the requirements are clear, and the way it makes sure that the requirements are clear is it forces us to define what the requirements mean in English. Then we together translate the English into code, and we run the code before we say we have finished the requirement. Huge difference. So we'll receive a story, we'll clarify, we'll write the English, we'll translate the English tests into code, and then we will start implementing it. BDD is oftentimes confused with acceptance test-driven development, in that BDD starts with English and ATDD doesn't make that requirement, though in real life most people get confused talking and will say ATDD and BDD and won't actually be able to distinguish between them. Tooling on BDD, most of it is Cucumber and Gherkin. That's not the only tooling available, but Cucumber and Gherkin is the core of what we tend to use for doing behavior-driven development. Behavior-driven development is where a lot of this stuff, given a user comes to the website and logs in, then when he goes to the My Profile page, then he sees his name in the top left corner, right? That's basically what a Cucumber script looks like. This code gets translated. This becomes a unit test, basically a Selenium test. This becomes a Selenium test. This becomes a Selenium test. And that becomes a Selenium test. And then we script those out. It's a really neat process. It's very powerful. It's mostly a way of getting your requirements good. Historically, Cucumber has used white box style testing, has used black box style testing where we only tested system boundaries. These days, a modern Cucumber is moving in other directions. We can talk about that. There's also other forms of automated testing: load testing, stress testing, performance testing, usability, acceptance, visual testing. We can cover the regression. We have automated load and stress and performance testing. Acceptance testing is not normally done in an automated fashion. Exploratory testing by users is usually not done in an automated fashion. And one last thing, and I'll stop talking. I'll stick around for a bit to answer questions, but I'll stop trying to present. Visual testing. There's a new set of tools out which are called visual tests or visual diffs. The one I'm most familiar with is called PDiff, perceptual diff. And what it does is when you build a website and you make a change to it, which of your automated tests checks to see if your font has changed? If the site still looks good? Well, none of them. So there's this tool, PDiff, which basically, when you run it with your builds, it takes a snapshot of most of your pages. It keeps it as a GIF. And then when you build it again, it takes the same snapshot. If your snapshots have changed substantially, it does not automatically publish the code. Rather, it says we need a manual override to publish the code. That way, you can't accidentally make big visual changes to your website without intending to. And we've all seen some of that happen when we have a bunch of manual testing and not the other stuff. So, overall line here. If you are doing Agile quality, it has to be automated. It has to include build deploy. You really need to be paying attention to testing your requirements too with something like BDD. Static analysis matters. Test quality matters. And then there's a whole bunch of other DevOps stuff like environment management and such that we have to work out, going down into branching strategies that I no way have enough time for here. I have reached my 2.5-hour limit of time. And so I have to say thank you for sharing your time with me. Apparently, one of our participants has dealt with some other visual diff stuff, some pdiff stuff, and it's called PyQt sandals. So, of course, if you give me a moment to advertise, what I like to do is actually come in and send some of my people in and actually teach people how to do all of this stuff rather than just overviewing what all the stuff is. Generally, it's about a 4-day class to do this whole sequence and go, here's how you do each one of these at least a little bit. Thank you for staying. Thank you for listening. I'll stick around for another 15, 20 minutes, maybe half an hour, and answer questions if anybody wants to chat. Once most of y'all are gone, and the questions stop happening, I'll shut down the webinar. I'm going to answer Philip's question out loud. Agile engineering supports Agile methodology better. Yes. Me and most of the people who were involved in Agile back in 2000 before the manifesto was signed are not altogether convinced that you can sustain Agile without the Agile engineering. Agile process is a nice start, but it's not really a sustainable system. You're asking software developers to make changes to the code too frequently, and you will mess up your code unless you adopt the Agile engineering behaviors. And so I would personally say it's stronger than you did, Philip. It's not that Agile engineering supports Agile better. It's that Agile engineering is necessary for sustainable Agile. You run into too many problems with how frequently you have to change your code if you don't do the Agile engineering practices and you do Scrum or something, or Kanban or something on a project for a couple years. That was a great question. Thank you for it.